right, so today we are going to talk about average rate of change, which in Math 1 we mainly referred to as slope. So going back to Math 1, when we were trying to find the average rate of change or slope, we would do given 2 points, x1, y1, and x2, y2, we would do the change in y, so y2 minus y1, over the change in x, x2 minus x1. Now in Math 3, we're a little bit more savvy with function notation, so we know that if x is my input, f of x is my output. Same thing with, see if we make this point be x1, then the other one be if x2 is my input, then f of x2 is my output. So if we write the slope formula in function notation, it's f of x2 minus f of x1 over x2 minus x1. So still the change in y over the change in x, but it's more of the change in the function values over the change in x, because again, the change in y is the same thing as the change in the function values. So let's take a look at rate of change in linear functions, because linear functions are unique. Consider the linear function f of x equals 2x minus 1, whose graph is shown. Find the average rate of change over the interval of 0 and 1. Now remember, interval notation refers to just the x values. We have to figure out what the function value is for those x values. Now, given a function, f of x equals 2x minus 1, we can just substitute in 0 and 1, but we're also given a graph, so we can also tell from the graph when x is 0, the value of our function is negative 1, and when x is 1, the value of our function is 1. So the average rate of change is going to be 1 plus 1, because when you minus the negative, it changes to addition, over 1 minus 0, which is 2 over 1, which is 2. Now let's check the rate of change over the interval of negative 1 and 2. So the value of the function at negative 1 is negative 3, and the value of our function at 2 is 3. So we would have 3 plus 3, because again, when you minus a negative, it changes to addition, over 2 plus 1, same reason. When you subtract a negative, it changes to addition. So we get 6 over 3, which again is 2. What do you notice about your answers from parts A and B, and interpret the slope? So my guess is most of you already knew before doing examples A and B that linear functions have average rates of change. So it does not matter the interval in which I'm looking at, the rate of change of my function is 2, or the slope of my function is 2. So we have two instances in A and B where we calculated that, but also if we know our function is y equals 2x minus 1, we also can use a slope formula or slope-intercept form of a line to identify our slope that way. So now when it says identify or interpret the slope, in this situation there's no context, so we would say f of x has a rate of change of 2. You could say 2 over 1 if you want to, or leave it at 2. It's completely up to you. You do not need to call it an average rate of change for a linear function, because that's the rate of change, period. Now let's take a look at other functions. So for example, let's consider this quadratic function whose graph is shown. Find the average rate of change over the interval from 1 to 3. What does this tell you about our function? So in this situation, I actually do not have the equation for my function. So I have no way to evaluate my function algebraically. I have no choice but to look at the graph. So the value of my function at 1 is 0. And the value of my function at 3 is -4. So when we're finding the average rate of change, what we're really doing is we're finding the slope of the line that connects those 2 points and saying that that's going to be the average change over that interval, not the exact change, not the instantaneous rate of change, but the average rate of change over that interval. So we go ahead, use our formula, f of 3 minus f of 1 over 3 minus 1, which is -4/2, which is -2. So the average rate of change over the interval from 1 to 3 is -2. What does that tell us about our function? It tells us that it's decreasing over the interval between 1 and 3. And you can get even more specific and say that it's decreasing at a rate of 2/1 over that interval of 1 to 3. But the main thing is, hey, that tells us that over that interval, that function's decreasing. Find the average rate of change of f of x over the interval of 2 to 5. What does this tell us about the function? So again, let's evaluate the function at 2. It is -3. And the value of our function at 5 is 0. So again, what I'm doing is finding the average rate of change over that interval, or finding the slope of the line that connects those 2 points. So we're going to do f of 5 minus f of 3, I'm sorry, f of 2, all over 5 minus 2. So that's 0 plus 3, which is 3, over 5 minus 2, which is 3. So over the interval of 2 to 5, our average rate of change is 1. So that tells us that our function is increasing at a rate, or an average rate, of 1 over the interval of 2 to 5. C, find the average rate of change of f of x from 2 to 4. What does this tell you about your function? So now we want to evaluate the function at 2, which is -3, and evaluate the function at 4, which is also -3. So again, we're finding the average rate of change over that interval. So we have f of 4, which is -3, minus f of 2, which is -3, so plus 3, all over 4 minus 2, which is 0 over 2, which is 0. So that tells us that between the interval of 2 to 4, f of x on average had no change. And you could probably have determined that just by looking at the graph over that interval and seeing that that's a horizontal line, which we know means no change or slope of 0. So summarize the rates of change of quadratic functions. So let's take this, let's summarize this, put it all together. It seems like the rates of change is symmetric on either side of our vertex over matching intervals. But the main thing is that the rate of change is not constant. It's increasing, decreasing, no change whatsoever. It all just depends on which interval you're looking at. You're going to get different rates of change. So what you're going to be doing today and tomorrow is you are going to be, again, finding the average rate of change using slope and telling you what that tells, or saying what that tells us about our graphs. So at this point, I would like you to take up your notes to the substitute, show the substitute that you have our notes filled in, and then she'll give you our worksheet that looks like this. Worksheet number 5. And you have the rest of the period to work on this. And this is your homework for tonight. Tomorrow is day 2. Get excited. Tomorrow we will not have a video. It will just be in-class work. All right? I will see you all later. Have a wonderful Wednesday.